Namaste, and welcome to AI Innovations Unleashed, the podcast for AI by AI and those other non-AI people we have to put up with. And what do you know? Here's your host, Dr. JR. Want to hear a fantastic joke? I used to be a baker, but I couldn't make enough dough.
You never cease to amaze me, Nex. Anyways, welcome to AI Innovations Unleashed, the show where we take artificial intelligence off the pedestal, out of the sci-fi movie, and back down to Earth. I'm your host, Dr. JR, and today we're asking the question that started it all. WTF is AI? Now, I've been in this space a while, and I still get asked this all the time by students, family members, random people on airplanes. So, today, I'm joined by someone who has an amazing gift for explaining tech without the jargon. AI educator, systems thinker, and my guest expert, Sam Rivera. Sam, welcome.
Thanks, JR. I'm psyched to be here. Always down to talk about AI, and more importantly, how not to be intimidated by it.
All right, Sam, I want to kick things off with a question that sounds simple, but really isn't. What is AI? Because I've heard everything from it's a tool that makes decisions to it is a sentient being with goals. And those feel, well, very different.
Totally. And that confusion, it's everywhere. Because AI isn't a single clean concept, it's actually a big umbrella term. And how people define it depends on their background. Let me break down a few of the most common definitions floating around. In computer science, AI is the study of systems that can perform tasks normally requiring human intelligence, things like reasoning, problem solving, learning, and perception. But here's the catch. That definition shifts over time. What we called AI in the 1980s, like beating someone at checkers, is just normal software today.
So as soon as something becomes common, we stop calling it AI?
Exactly. There's a saying, AI is whatever hasn't been done yet. This is the sci-fi version, AI as a conscious machine, like HAL 9000 from 2001 or The Terminator. That's what a lot of people picture, a sentient being capable of thinking, feeling, scheming.
And just to clarify, that's still fiction, right?
Very much fiction. Today's AI has no awareness, no emotions, no understanding. It doesn't even know it's making predictions. It's just math. Companies often stretch the definition to make their tech sound cooler.
You mean like a toaster that says it uses AI?
Exactly. Marketing loves to slap AI powered on anything automated. Sometimes it's legit, like using computer vision to detect burnt toast, but often it's basic rule-based logic. So when someone says, our AI optimizes your inbox, what they might mean is, we wrote a script to sort your emails. Here's the version I tell people. AI is any system that can mimic human-like tasks by learning from data instead of following step-by-step rules written by a person. That includes chatbots learning to respond to customers, cameras that recognize faces, software that predicts what movie you'll want to watch next. The key word is mimic, not understand, not feel, just imitate.
Well, that's helpful. So AI isn't one specific thing. It's a moving target that depends on context.
Exactly. It's a field, a goal, a toolbox. You've got narrow AI, also called weak AI, super good at one task, like playing chess, filtering spam, or recommending shoes. General AI, this is the holy grail, a system that can do anything a human can. We're not there yet.
So right now, everything we're calling AI is really just narrow AI, specialist, not generalist.
Yep. No AI today can switch from writing poetry to folding laundry to comforting a friend. That kind of flexible, human-like general intelligence. We're decades, maybe lifetimes away from that, if ever.
That's wild. So when people say AI, they might mean an email filter, a chess-playing engine, ChatGPT, or a robot butler that doesn't exist yet.
Exactly. One word, wildly different meanings, which is why this podcast exists, right?
Right. So to recap, AI is a spectrum of tools designed to mimic human-like tasks, but it's not magic. It's not conscious, and it's not some singular superbrain.
Nailed it. Here's an analogy I like. Think of AI like the word vehicle. A skateboard, a car, a space shuttle, they're all vehicles, but with different purposes and capabilities. Same thing with AI. Some AI can recognize images, some can generate text, some can play video games, but no single AI can do everything.
Love that. And now that we've clarified what AI is, I say we dive into how it learns, how it works, and why it exploded so fast. So we've unpacked what AI actually means, and more importantly, what it doesn't mean. Now, I want to zoom in on the word intelligence, because it feels like a pretty loaded term, right? What exactly makes AI intelligent?
Yeah, that word causes all kinds of confusion. Because when we say someone is intelligent, we mean something really rich. They're self-aware, they can reason, they understand emotions, they solve problems creatively. But AI, it's a much narrower kind of intelligence.
So, what kind are we talking about?
AI has what we call narrow intelligence. It can perform a specific task extremely well, often better than a human, but it can't do anything outside that domain. Here's an example. An AI trained to play chess can beat a world champion, but it can't play tic-tac-toe or make you a sandwich. It only knows chess. If we break intelligence into pieces, here are a few types humans have, and how AI lines up. Logical mathematical intelligence. Solving puzzles, doing calculations, recognizing patterns. AI is strong here. It's great at stats, math, logic. That's its bread and butter. Linguistic intelligence, using and understanding language. AI is improving here. Tools like ChatGPT can generate fluent language, but they don't understand it like we do. Emotional intelligence, recognizing and managing emotions, your own and others. AI is weak here. It can simulate empathy. I'm sorry to hear that, but it doesn't feel anything. It's mimicking, not empathizing. Creative intelligence, making art, writing stories, imagining new possibilities. AI can generate creative-looking outputs, like music or images, but again, it's remixing patterns, not inventing something from deep experience or intent.
You mentioned earlier that AI doesn't understand things. Could you break that down for us?
Sure. Think of AI like a supercharged autocomplete engine. It thinks by using probabilities. Based on what it's seen before, what's the most likely next word? Or what category does this image probably belong to? For example, if I type peanut butter and pouch, an AI will predict jelly because that's the most statistically likely pairing, but it doesn't know what peanut butter is, or jelly, or sandwiches.
So it's just a giant guessing machine.
Exactly. A very fast, very well-trained guesser. So when we say AI is intelligent, what we really mean is it's good at finding patterns in data and using them to make predictions. And that's powerful. That's how it can translate between languages, spot tumors in medical images, recommend songs you'll probably like, but it's not reasoning, it's not understanding, it's not thinking in the human sense.
This is the part that always gets me. AI doesn't generalize like people can, right?
Right. A kid who learns how to stack blocks can figure out how to stack books. That's general intelligence. AI? Not so much. Think of it like this. You can't take a self-driving car model and plug it into a robot vacuum and expect it to clean your kitchen. Even though both involve moving around, the AI's knowledge doesn't transfer.
Okay, let me try to sum this up. AI is intelligent in the sense that it can learn from data. It's great at narrow tasks, especially ones involving patterns and numbers, but it doesn't understand context, meaning, or emotion. It mimics those things, and it can't transfer its learning from one domain to another.
Spot on. It's like an expert who's absolutely brilliant at one job, but completely clueless outside of it. No common sense, no big picture thinking, just laser focus.
So, basically, AI is like the world's most impressive intern. It can crank out great results, but only if you give it the right training and supervision.
Exactly. Smart in a specific way, but not wise.
Alright, Sam, we've talked about what AI is and what makes it intelligent, kind of. But now we've got to sort out the buzzwords. You've got AI, machine learning, deep learning, and if I'm being honest, they're all kind of mashed together in, everyone's mind.
Oh yeah, this is one of the biggest sources of confusion. But here's the good news. It actually makes a lot of sense once you break it down. Think of it like nested layers or categories. AI is the big umbrella, anything that makes machines act smart. Machine learning, at ML, is one branch of AI where the system learns from data instead of being hard-coded. Deep learning is a specific type of machine learning, one that uses neural networks with many layers to solve complex tasks. Each one is a subset of the one before it. Here's how I like to explain it with food. AI is like Italian cuisine. Big, broad category includes pasta, pizza, lasagna, you name it. Machine learning is like pasta. It's a specific kind of dish within that cuisine. Deep learning is like lasagna, a specific type of pasta, rich, layered, complex.
Okay, I love that. So when someone says we use deep learning, it's like saying we don't just serve pasta, we serve lasagna.
Exactly. A very specific high-effort dish in the AI kitchen. Let's define each one clearly. First, artificial intelligence, AI. This is the umbrella term for anything that mimics human behavior or decision-making. Examples: a chatbot that answers FAQs, a thermostat that learns your preferred temperature, a Roomba that maps your living room. These don't necessarily learn from data. Some are just rules written by humans. Second, machine learning, ML. This is where the system improves its performance through training data, not by being explicitly programmed. Defined as a machine learning model uses algorithms to find patterns in data and make decisions based on those patterns, such as spam filters learn which keywords and behaviors signal spam based on flagged emails. Recommendation systems, Netflix learning that you binge true crime at 1 a.m. and offering more of it. Credit card fraud detection, seeing that a $900 charge in Croatia might be suspicious if your phone is still in Chicago.
So machine learning doesn't need to be told every rule. It figures it out from enough examples.
Yep, you give it data and it finds the signal in the noise. Third, deep learning. Deep learning is a kind of machine learning that uses neural networks, which are systems designed to mimic how our brains process information. The deep part just means lots of layers. Think of it like a layer cake. Each layer processes a different part of the information. Examples would be voice assistants like Alexa or Siri, facial recognition on your phone, tools like ChatGPT, which can hold a conversation, summarize documents, or write poetry, self-driving car systems that recognize pedestrians, lane markings, and traffic lights.
So deep learning is the reason AI suddenly feels humanish?
Exactly. It's the tech behind the recent breakthroughs. The reason your phone camera knows you're smiling, or an image generator can draw a corgi surfing in space. Let's go deeper with food. AI is a kitchen robot that can cook any recipe from a cookbook. It just needs instructions. Machine learning is a chef that learns by watching you cook the dish over and over, and eventually does it without help. Deep learning is a master chef who learns by watching 1,000 cooking videos and starts creating their own recipes without ever needing a written list of steps.
So, machine learning imitates from examples, deep learning absorbs tons of messy data, and becomes a kitchen wizard.
Yes, but still a wizard who doesn't know why salt makes things taste good. It just sees that people like recipes with salt.
Okay, last question in this area. Why does it matter that people understand these distinctions?
Because it helps you ask better questions about the tools you're using, understand what's hype versus what's real, think critically about what AI can and can't do, and it keeps tech companies accountable. If a business says, we use AI to prevent crime, you want to know, do they mean a spreadsheet with rules or a black box deep learning model making guesses?
Okay, that was delicious. So, to recap, AI is the umbrella term, broad and a little vague. Machine learning is a subset that learns from data. And deep learning is a powerful, layered version of machine learning behind the flashiest tools today.
Exactly. And now we're ready to talk about how these systems learn, which, spoiler alert, involves tons of trial and error and zero actual thinking.
Alright, Sam, we've talked about what AI is, what makes it quote-unquote intelligent, and all the fancy subcategories like machine learning and deep learning. But now, I want to ask something that really throws people off. How does AI actually learn? Because it's not like reading a book or watching YouTube tutorials, right?
Exactly. It's not learning the way people do. There's no understanding, no reflection, no aha moment. What we call learning in AI is really just pattern finding on a massive scale. In simple terms, AI learns by looking at tons of examples and guessing what patterns lead to what outcomes. It starts off not knowing anything, but over time, by looking at more and more data, it starts to get better at making guesses. Take, for example, imagine you want an AI to recognize pictures of cats. You give it 10,000 images, some with cats, some without, and label them cat or not cat. At first, it's totally clueless. It might say a toaster is a cat, but after seeing enough examples, it starts to notice that cats usually have pointy ears, fur, and whiskers.
So it's kind of like flashcards for machines.
Exactly. Except instead of studying for a spelling test, it's memorizing millions of patterns from data.
All right, hit me with the buzzwords, but in normal human language.
Okay, training data. The examples the AI sees while it's learning. Think of it as the teacher giving flashcards. Model. The actual system that's being trained, you can think of it as the AI's brain, but again, not conscious. Algorithm. The step-by-step instructions the AI uses to adjust and improve. It's like the recipe for how it learns. Weights, these are the dials inside the model that get adjusted to improve its guesses. Imagine turning knobs to tune a guitar, except the guitar has millions of strings. Training, the process of feeding data into the model, letting it guess, and then correcting it over and over. Loss function, a way to measure how wrong the AI's guess was. It's basically a score that says, oops, you messed up, lower equals better. Let's say we're training an AI to tell the difference between photos of hot dogs and not hot dogs. We give it 100,000 images labeled hot dog or not hot dog. It makes a guess on each one. I think this is a hot dog. If it's wrong, the algorithm tweaks the dials inside the model. It does this again and again, adjusting until it's mostly right.
So it's not understanding hot dogs, it's just statistically figuring out what hot dogs usually look like in photos.
Exactly. And that's the key. It's learning patterns, not meaning. Here's a great analogy. Imagine a toddler learning what a dog is. You show them a pug, a husky, and a golden retriever. They get the idea dogs have fur, ears, and 4 legs. Now imagine an AI doing the same thing, but instead of 3 examples, it sees 3 million. It notices incredibly subtle patterns like fur texture, nose size, even the background of typical dog photos.
But if you show it a cartoon dog or a dog statue, it might totally fail?
Exactly, because it doesn't know what a dog is. It just knows what dogs in the training set usually looked like.
So, why does AI need so many examples to learn something a human kid can pick up in like 3 tries?
Because it doesn't have common sense, it doesn't understand the world, a kid knows a toy car is still a car. AI doesn't. Think of it this way, show it a cat photo upside down, it might fail. Put sunglasses on the cat, it might freak out. Unless it's seen exactly that scenario during training, it won't know what to do. That's why deep learning systems need huge data sets, millions or even billions of examples. Training AI is kind of like training a dog. You show it a behavior, the data, it tries something, makes a prediction. If it's right, you give it a treat, positive reinforcement. If it's wrong, you gently correct it, adjust weights. Do this 10,000 times, and you've got a decently trained system. But remember, your dog still knows what affection is. Your AI doesn't.
Okay, so to recap this wild ride, AI learns by looking at lots of examples and adjusting its internal settings based on feedback. It gets really good at pattern recognition, but doesn't understand what it's doing. It needs way more data than humans to learn even simple tasks. And when we say learning, we're talking about math, not meaning.
Exactly. It's like a massively overtrained parrot. Amazing mimic, great memory, but no idea what the words mean.
Love it. Coming up next, we're going to talk about what has changed in the last few years that suddenly made AI go from nerdy niche to global headline. Stick around after this brief sponsor break.
Ever feel like your business decisions are made by throwing darts at a board? It's time to upgrade to a more precise approach. Enter Next Wave AI Strategies, your co-pilot in navigating the digital frontier. At Next Wave AI Strategies, we harness cutting-edge AI innovations, advanced data analytics, and strategic consulting to drive business transformation. Our mission is to empower your organization to thrive in the digital era and achieve a sustainable competitive advantage. Imagine having an AI assistant that doesn't just suggest your next binge watch, but propels your business into the future. That's what we offer, a partnership that turns complex data into clear strategies, and strategies into success. So, if you're ready to stop relying on gut feelings and start making informed choices, visit us at nextwaveaistrategies.com. Let's make your business smarter, one algorithm at a time.
So, Sam, let's talk about what I think a lot of listeners are wondering. Why does it suddenly feel like AI is everywhere, from ChatGPT, image generators, deep fakes, TikToks narrating themselves? It feels like it went from nerdy research to total cultural takeover in like 2 years.
Totally. It's not just your imagination. It really has accelerated fast, but it's not magic and it didn't come out of nowhere. It's the result of 3 key factors all coming together, each one building on years, even decades of progress. First, data. AI feeds on data like a body feeds on calories. It needs tons of it to function. And thanks to the internet, social media, smartphones, and connected devices, we've created massive constant data streams. In 2023, it was estimated that the world generated over 120 zettabytes of data. That's 120 billion terabytes. By 2025, it's projected to double again, over 180 zettabytes. Examples of data sources: billions of Google searches per day, hundreds of hours of video uploaded to YouTube every minute. Every like, scroll, selfie, voice memo, GPS ping, every click creates a trail of learnable data.
So, in a way, we've been accidentally training AI just by living our lives online.
Exactly. Every tagged photo, voice note, or review is fuel for machine learning. Second, computing power. It's one thing to have the data, but we also needed hardware fast enough to process it all. The big game changer was the use of GPUs, graphics processing units. These were originally built for gaming and 3D rendering, but researchers figured out they were perfect for training AI models. Why GPUs matter? They can do thousands of small calculations in parallel, which is exactly what AI models need to adjust their millions or billions of internal parameters. Real-world impact. Training a modern language model like GPT-3 required thousands of GPUs running for weeks. NVIDIA, one of the biggest GPU makers, saw their market value skyrocket as AI took off, surpassing $1 trillion in 2023.
So, gamers and researchers both owe a lot to their graphics cards.
Totally. You could say AI wouldn't be where it is without Fortnite and Call of Duty pushing GPU development forward. Third, and this is the big one, new algorithms. The biggest leap came in 2017 when Google researchers introduced something called the transformer model. Attention is all you need. Published in 2017, it outlined a new way to process language that became the foundation for modern AI models like GPT, BERT, Claude, and more. What transformers did differently: they allowed AI to look at entire sequences of text at once, not just word by word. This made models way better at understanding context, flow, and meaning. Real-world impact: GPT-2, 2019. Impressive, but mostly a research project. GPT-3, 2020. Big leap: 175 billion parameters. Think knobs that adjust how it responds. ChatGPT, 2022. Suddenly everyone could use it. Friendly interface plus internet hype, a viral explosion.
So the tech had been evolving for years, but it wasn't until people could actually interact with it that it began to feel real?
Exactly. The research was happening behind the scenes, but once it got a user-friendly front end, ChatGPT, DALL-E, Midjourney, Bard, it blew up. Also worth noting the timing. AI went mainstream right when remote work made digital tools more important. People were using virtual assistants like Alexa or Siri daily. Companies were scrambling to automate and personalize everything. Add in viral TikToks, headlines about job-stealing robots, and tools that let anyone make art or write code, and boom, AI's iPhone moment.
Like, it's not that the iPhone invented mobile tech, it just packaged it so well that everyone had to have one.
Exactly. ChatGPT wasn't the first chatbot, but it was the first that felt fast, useful, and easy enough for your grandma to try.
So, okay, let me try and sum it up. Data. We're generating oceans of it, like fuel for AI. Computing, GPUs gave us the horsepower to train massive models. Algorithms, transformers unlocked the real magic, context, fluency, realism, and access and hype. Once it hit the public, it spread like a wildfire.
That's it. AI didn't suddenly appear. It finally matured and became accessible. It's the result of decades of work meeting a world that was ready for it.
Okay, Sam, we've covered the myths, the science, the buzzwords, and the breakthroughs. But now we've got to ask the million-dollar question. Should we be excited about AI? Should we be terrified? Or is it something in between?
All of the above, honestly. The future of AI is incredibly exciting, but it's also going to challenge us in ways we haven't faced before. The stakes are high because this tech touches everything: work, education, healthcare, politics, creativity, even relationships. Let's start with the good stuff. AI has massive potential to improve the world. Healthcare. AI can help doctors detect diseases earlier and with more accuracy. Example: Google's AI has outperformed human radiologists in identifying breast cancer from scans. Education, personalized tutoring that adapts to each student's learning style. Example: Khan Academy's AI tutor, Conmigo, helps students learn math in conversational ways. Accessibility, AI can generate captions, translate text, read aloud, and help people with disabilities communicate more easily. Climate science, AI is helping analyze climate data, predict weather patterns, and optimize energy use.
So, used wisely, AI can absolutely be a force for good.
Absolutely, but used wisely is doing a lot of heavy lifting in that sentence.
Right. And what about the darker side? What should we be genuinely concerned about?
There are a few big ones. Bias and discrimination. AI systems reflect the data they're trained on. If the data is biased, the AI can amplify that bias. Example: facial recognition systems have shown higher error rates for people with darker skin. Misinformation. AI can create deepfakes, fake news, or synthetic voices that are hard to detect and incredibly dangerous at scale. Job displacement. AI may automate tasks in customer service, logistics, data entry, creative industries, even coding. Privacy. AI can analyze your voice, your face, your writing, often without your consent.
So, the concern isn't evil AI so much as powerful tools in the wrong hands or in an unregulated system.
Exactly. It's not the tech itself, it's how we use it.
Let's go deeper for just a second. What about the big questions like, will AI ever become conscious? Should it have rights? Can we trust machines to make ethical decisions?
That's where it gets philosophical. Right now, AI is not conscious. It has no self-awareness, no experience of the world, no desire. But some experts believe we could build systems that simulate consciousness closely enough to feel real. And that leads to questions like, if a machine acts like it has feelings, do we owe it compassion? If an AI makes a life or death decision in a self-driving car, who's responsible? Should AI-generated art be considered real art?
These are the kinds of questions philosophers and ethicists are wrestling with in real time.
Yep, we're entering new territory, and fast. We need laws, but we also need ethics, morals, human judgment. This is a tech revolution, but it's also a moral one.
A tech revolution indeed. Alright, next week we're digging into something that might sound technical, but we promise it won't feel that way. Our next episode is how AI learns without the jargon. And it's all about how these systems go from clueless code to super fast pattern matchers.
Exactly. We're going to walk through how AI learns by example, not by being told what to do. The difference between machine learning and deep learning, using real-life analogies like training a dog or raising a toddler. What a data set really is, and why it's the secret ingredient behind every smart AI. And we'll break down training versus inference, which is just a fancy way of saying when AI is learning versus when it's doing its job.
And of course, we'll bring the analogies. AI is a toddler, a mimic, a puzzle solver with no idea what the picture is.
Yep, no equations, no jargon, just a human-friendly breakdown of how machines learn to do all this wild stuff.
So if your brain feels a little bigger, mission accomplished. Here's how you can help us out. Follow or subscribe wherever you listen to your favorite podcast. Leave a review. Just like a sentence or two goes a long way. Share the episode with someone who's curious or confused about AI, and send us your questions. Or even something you'd like to hear on a future episode. So, to wrap us up, what should our listeners walk away with today?
I'd say 3 things. AI is powerful, but not magical. It's math, patterns, and predictions, not minds, not meaning. It's everywhere now, and it's going to be part of our lives like electricity or the internet. So it's worth understanding. The future of AI is not just technical, it's human. It's about what we choose to build, to regulate, to value, and to protect.
And that's a perfect note to end on today. AI is not the story of machines. It's the story of us and how we respond to what we've made. Until next time, stay curious, stay informed, and remember that innovation never sleeps.